Across hospitals, research labs, and controlled clinical environments, there are documented human cases that defy clear explanation. Individuals who remember everything, bodies that resist natural limits, and conditions that appear without cause have been studied, recorded, and left unresolved. Medical records exist, but answers do not. In this video, we'll break down 6 unexplained human phenomena that science has yet to fully understand. The man who could remember every day of his life. In 2006, researchers at the University of California, Irvine published a case study that would draw quiet attention across the neurological community. The subject, identified publicly as Jill Price, was a woman in her early 40s who claimed she could remember nearly every day of her life in extraordinary detail. According to her own written accounts, she could recall specific dates, the day of the week, what she had done, what she had worn, and even what had been reported in the news on that exact day. Her memory was not based on diaries or records. She insisted it was automatic, involuntary, and constant. When she contacted neuroscientist Dr. James McGaugh, she described her ability not as a gift, but as a burden. She wrote that her mind was like a running movie that never stops, replaying years of past events without control. During initial testing, researchers selected random dates spanning decades. Price responded quickly and consistently, identifying personal events tied to those dates and accurately placing them within a broader historical context. In one documented session, she was asked about March 19th, 1985. Within seconds, she stated the day of the week, described what she had eaten for lunch, and referenced a news story about a specific airline incident that occurred that same day. Independent verification confirmed the accuracy of both her personal and historical recollections. Over time, the research team conducted controlled tests to rule out rehearsed memory or external aids. They found no evidence that she relied on notes, calendars, or mnemonic strategies. Brain imaging studies were conducted to identify any structural differences. MRI scans revealed slight variations in regions associated with autobiographical memory, particularly in the caudate nucleus and temporal lobe. However, these differences were subtle and did not fully explain the scale or consistency of her recall. There was no indication of abnormal brain damage, tumor, or neurological disease. Her intelligence level tested within the normal range, and she did not demonstrate exceptional performance in other types of memory, such as memorizing random numbers or abstract patterns. Her ability appeared to be highly specific to personal life events tied to dates. Researchers later classified her condition as highly superior autobiographical memory, or HSAM, a term created after her case became widely studied. What made Price's case unusual was not only the precision of her recall, but its persistence. She reported that memories surfaced automatically, often triggered by dates or passing thoughts, and that she had no way to suppress them. She described reliving emotional experiences from decades earlier with the same intensity as when they first occurred. According to clinical notes, this constant recall interfered with her daily functioning, making it difficult to move past negative experiences. She told researchers that she could not forget arguments, losses, or moments of distress even after many years. As the study gained attention, other individuals came forward claiming similar abilities. A small number were later confirmed to exhibit comparable patterns of autobiographical recall, though none matched Price's consistency across such a wide time span. Despite these additional cases, scientists were unable to identify a single neurological or genetic cause. Some researchers suggested that obsessive tendencies or repeated mental rehearsal might contribute, but these explanations did not fully account for the automatic nature of the recall or its accuracy across decades. Psychological evaluations of Price showed no signs of fabrication or delusion. Her responses remained stable over repeated testing, and independent verification consistently supported her claims. In interviews, she maintained that she had experienced this condition since adolescence, though she initially believed it was normal. It was only later, after comparing her experiences with others, that she realized the extent of the difference. One of the most unusual aspects documented in the case was her ability to link personal memory with external timelines. When presented with a historical date, she could often describe not only what occurred in the world, but exactly how she had experienced that day, including location, weather, and emotional state. Researchers noted that this integration of personal and public memory was highly atypical and not fully understood. Over time, the case became a reference point in memory research, raising questions about how the brain encodes and retrieves autobiographical information. Despite years of study, no clear mechanism was identified that could explain why her memory functioned in this way while others did not. There was no treatment proposed, no method to replicate the ability, and no consensus on whether it should be considered a disorder or an extreme variation of normal memory. In follow-up interviews, Price continued to describe her condition as intrusive and exhausting. She stated that every date carried weight, that every passing day added to an ever-growing archive she could not escape. Researchers eventually concluded their formal study without reaching a definitive explanation. Her brain scans remained inconclusive, her psychological profile remained stable, and her memory continued to function in a way that existing models could not fully account for. The case was documented, reviewed, and archived, but the central question remained unresolved. The woman with extreme sensitivity to electromagnetic fields. In 2015, a series of clinical reports began circulating within Swedish and German research circles, describing a patient identified as Anna Lindström, a 38-year-old former administrative assistant from Uppsala, Sweden, who claimed that exposure to common electronic devices caused immediate and severe physical reactions. According to medical records from Uppsala University Hospital, Lindström reported symptoms that included sharp headaches, skin tingling, heart palpitations, and a sensation she described as pressure inside the skull whenever she was near active Wi-Fi routers, mobile phones, or computer monitors. Her complaints were initially categorized as stress-related or psychosomatic, a classification often applied to similar cases of what is informally known as electromagnetic hypersensitivity. However, Lindström insisted that her reactions were consistent, predictable, and measurable. In early consultations, physicians conducted standard neurological and cardiovascular tests, all of which returned results within normal ranges. There was no evidence of epilepsy, cardiac irregularity, or dermatological condition. Despite this, her symptoms persisted and reportedly intensified over time, eventually forcing her to leave her job due to the presence of office electronics. In 2016, her case was referred to a small interdisciplinary research group affiliated with the Karolinska Institute, where more controlled testing was arranged. The experimental design involved blind exposure sessions in which Lindström was placed in a neutral, shielded room and exposed intermittently to electromagnetic fields generated by concealed devices. During these sessions, neither Lindström nor the supervising clinicians were informed when the devices were active. According to the official report, her ability to consciously identify exposure periods was inconsistent and statistically inconclusive. However, physiological monitoring told a more complex story. During certain exposure intervals, her heart rate increased slightly, and minor but measurable changes in skin conductance were recorded. These changes did not occur consistently across all trials, but they appeared more frequently during active electromagnetic exposure than during control periods. Researchers noted the irregular pattern but could not establish a direct causal link. Further investigation focused on environmental variables outside the laboratory. Lindström documented her daily experiences in a detailed log over several months, noting the timing and intensity of her symptoms in relation to her surroundings. Independent reviewers compared her entries with known electromagnetic activity levels in specific locations, including public transportation systems, office buildings, and residential areas. In some cases, there was a partial correlation between high electromagnetic density and reported symptom onset, but the data remained fragmented and inconclusive. In one documented incident from October 2016, Lindström reported acute symptoms while traveling on a commuter train between Uppsala and Stockholm. According to her statement, she experienced sudden dizziness and a burning sensation across her forearms shortly after the train entered a densely populated urban zone. Medical evaluation conducted later that day found no visible injury or abnormality, but her account was consistent with previous reports. Attempts were made to replicate this scenario under controlled conditions, but results varied. As the case gained limited attention within academic circles, it also attracted skepticism. Several researchers argued that the physiological responses observed could be attributed to anxiety or conditioned stress responses, particularly given the lack of consistent detection during blind trials. Others pointed out that the measurable changes, though subtle, could not be entirely dismissed, especially in the absence of a clear psychological diagnosis. Lindstrom underwent multiple psychological evaluations over the course of 2 years. According to clinical summaries, she did not exhibit signs of delusion, paranoia, or somatic symptom disorder. Her cognitive function remained stable, and her responses during interviews were described as coherent and consistent. She acknowledged the possibility that her condition might not be fully understood, but maintained that her symptoms were physical and involuntary. In 2017, a follow-up study attempted to use functional MRI scanning to observe her brain activity during controlled exposure to electromagnetic fields. The results showed minor fluctuations in regions associated with sensory processing, but the variations were within a range that researchers could not definitively classify as abnormal. The imaging did not provide a clear mechanism or explanation for her reported sensitivity. By 2018, Lindstrom had relocated to a rural area with limited electronic infrastructure, reporting a noticeable reduction in symptom frequency. However, she stated that even minimal exposure, such as passing vehicles or distant communication towers, could still trigger mild reactions. Her case remained under periodic review, but no formal diagnosis was established beyond the descriptive label of electromagnetic sensitivity. The final report, published in a limited access medical journal, concluded that while subjective symptoms were consistently reported, objective measurements remained variable and insufficient to support a defined medical condition. Despite years of observation, controlled testing, and interdisciplinary analysis, no consensus was reached regarding the origin or validity of her condition. The case was neither confirmed nor dismissed, and no treatment protocol was proposed. Lindstrom's medical file remained open, categorized under unexplained environmental sensitivity, with notes indicating that further research would be required to determine whether her responses represented an unidentified physiological mechanism or a complex interaction between perception and physical stimuli. The person who could stay awake for days without fatigue. In late 2011, a clinical observation recorded at the Mount Sinai Sleep Center in New York began to draw quiet attention among specialists studying sleep disorders. The subject, identified in medical documentation as Daniel Harper, was a 27-year-old software technician who had been referred for evaluation after reporting an unusual pattern of prolonged wakefulness without apparent cognitive or physical decline. According to intake records, Harper claimed he could remain awake for periods exceeding 5 consecutive days without experiencing fatigue, disorientation, or the typical symptoms associated with sleep deprivation. His case initially emerged after coworkers reported that he appeared to be continuously active during extended project deadlines, often responding to messages at all hours with no noticeable drop in performance. During preliminary interviews, Harper described his condition in neutral terms, stating that he did not feel a need to sleep in the same way others did. He reported that while he occasionally chose to rest for short intervals, he did not experience drowsiness or the gradual onset of sleep pressure. He denied the use of stimulants, including caffeine beyond minimal intake, and toxicology screenings conducted upon admission supported this claim. His medical history showed no prior neurological disorders, psychiatric diagnoses, or substance abuse. Standard cognitive assessments placed him within a normal to above average range, with no indication of impairment. In December 2011, Harper agreed to undergo a controlled observation period within the sleep center. He was placed in a monitored environment for continuous recording, including electroencephalogram tracking, heart rate monitoring, and behavioral observation. The initial phase lasted 72 hours, during which Harper remained awake without prompting. Throughout this period, clinicians documented stable attention, coherent speech, and consistent reaction times during scheduled testing intervals. He completed memory tasks, problem-solving exercises, and motor coordination tests with results comparable to baseline measurements taken at the beginning of the study. There were no signs of microsleeps, which are typically observed in sleep-deprived individuals, nor any measurable lapses in awareness. Encouraged by these findings, researchers extended the observation period. By the 5th day, Harper continued to exhibit stable physiological markers. His EEG readings showed patterns consistent with wakefulness, with no intrusion of sleep stage activity. His cortisol levels and circadian rhythm indicators remained within expected ranges, though slightly flattened, suggesting a disruption in typical sleep-wake cycles without corresponding fatigue. Medical staff noted that while his behavior remained consistent, there was a subtle reduction in spontaneous activity, though not to a degree that indicated impairment. On the sixth day, the study was paused due to institutional guidelines limiting prolonged sleep deprivation experiments. Harper was then allowed to rest. According to reports, he fell asleep within minutes and remained asleep for approximately 4 hours before waking spontaneously. Upon waking, he reported feeling no different than before the sleep period and resumed normal activity without delay. Follow-up testing showed no cognitive decline or physical abnormalities. Over the following months, Harper participated in additional shorter observation sessions, each yielding similar results. Researchers attempted to identify any underlying mechanisms that could account for his condition. Genetic testing was conducted to look for known mutations associated with short sleep phenotypes, such as those affecting the DEC2 gene. Results showed no recognized variants linked to reduced sleep need. Brain imaging, including MRI and PET scans, revealed no structural abnormalities or unusual metabolic activity. His neurological profile remained indistinguishable from that of typical subjects. Psychological evaluations were also conducted to rule out conditions such as mania or hyperarousal disorders. Clinicians found no evidence of mood instability, impulsivity, or behavioral patterns consistent with psychiatric explanations. Harper maintained stable emotional responses and demonstrated consistent judgment across multiple assessments. In early 2012, a longer-term monitoring phase was proposed, involving wearable tracking devices to record his sleep patterns outside the clinical environment. Data collected over a 3-month period indicated that Harper averaged between 4 and 6 hours of sleep per week, often in short, irregular intervals. Despite this, his daily functioning remained stable according to both self-reports and third-party observations from colleagues and family members. There were no recorded incidents of accidents, memory lapses, or performance decline. One notable entry in the monitoring log described a 96-hour continuous wake period during which Harper completed a full work schedule, attended social events, and engaged in routine activities without interruption. His physiological data during this time showed no markers typically associated with sleep deprivation stress. As the case was reviewed, some researchers suggested the possibility of undetected microsleep episodes too brief to be captured by standard monitoring, though no direct evidence supported this theory. Others considered the potential for an unknown regulatory mechanism within the brain that allowed for reduced sleep dependency. However, no existing model of sleep biology could fully account for the observed data. By mid-2013, formal study of Harper's condition was reduced due to funding limitations and the absence of measurable progression or decline. His case was documented in a series of internal reports and later referenced in a limited number of academic discussions on atypical sleep patterns. No diagnosis was assigned and no treatment was recommended. Harper continued his daily life without reported complications, maintaining employment and routine activities. His medical file remained categorized under unexplained sleep-wake irregularity, with notes indicating that his condition did not align with any recognized disorder or adaptation. Despite controlled observation, repeated testing, and extended monitoring, the central question remained unresolved, as his ability to function without sleep beyond known human limits persisted without a clear biological explanation. The child who demonstrated advanced skills without training. In September 2008, a case documented by educational psychologists in the city of Denver, Colorado, began to circulate quietly among specialists studying cognitive development. The subject was a 7-year-old boy named Ethan Morales, a second-grade student with no prior record of exceptional academic performance, who suddenly demonstrated the ability to solve advanced mathematical problems well beyond his grade level. According to school records, Ethan had been performing at an average level in all subjects until early that year, when his teacher, Laura Jennings, noticed a shift in his behavior during routine classroom exercises. During a lesson on basic multiplication, Ethan began writing out solutions involving multi-digit numbers, including operations that had not yet been introduced in the curriculum. When questioned, he provided correct answers and showed intermediate steps consistent with formal mathematical training. Jennings initially assumed he had been exposed to the material outside of school, possibly through a parent or private tutoring. However, interviews with his family revealed no such exposure. His parents stated that neither of them had advanced mathematical backgrounds and that Ethan had not shown any particular interest in numbers prior to the change. In October 2008, the school arranged for Ethan to be evaluated by a district educational specialist. During controlled testing, he was presented with a series of progressively complex problems, including algebraic equations and basic calculus concepts. Observers noted that Ethan approached each task methodically, writing out steps and arriving at correct solutions in a manner consistent with formal instruction. When asked to explain his reasoning, he provided clear but simplified explanations, often stating that he just knew what to do next. There was no evidence of memorization or guessing. His responses remained consistent across repeated sessions. As the case drew attention, Ethan was referred to the University of Colorado's Department of Psychology for further evaluation. Researchers conducted a comprehensive assessment, including IQ testing, memory evaluation, and neurological screening. His general intelligence score fell within the high average range, but not at a level typically associated with prodigious abilities. His memory tests showed no exceptional recall beyond normal limits, and his language skills remained age-appropriate. Brain imaging conducted as part of the study revealed no structural abnormalities or unusual activity patterns. Despite this, his mathematical performance continued to exceed expectations. In one documented session, Ethan was presented with a problem involving quadratic equations, a concept typically introduced several years later in formal education. He solved the equation correctly and wrote out a process resembling the quadratic formula, though he had never been taught this method. When researchers asked where he had learned it, he responded that the steps made sense and that he could see how the numbers fit together. His explanation lacked formal terminology but demonstrated an understanding of the underlying structure. Investigators also examined the possibility of external influence or prior exposure through digital media. A review of the family's internet usage, television content, and reading materials found no evidence of advanced mathematical instruction. His parents reported that Ethan spent most of his free time engaged in typical activities for his age, including playing outside and watching standard children's programming. There were no indications of hidden tutoring or unauthorized access to educational resources. In early 2009, Ethan's case was presented at a regional conference on child cognition, where it generated cautious interest. Some researchers suggested that he might possess an unusual form of intuitive reasoning, allowing him to recognize patterns without formal training. Others proposed that he could have been exposed to information in ways not captured by standard investigation, though no direct evidence supported this. Over the following months, Ethan continued to demonstrate advanced problem-solving abilities, not only in mathematics but also in basic physics concepts. In one classroom observation, he correctly predicted the outcome of a simple mechanical experiment involving pulleys, providing an explanation that aligned with principles of force distribution. However, his abilities remained inconsistent across other subjects. His reading comprehension and writing skills did not show similar advancement, and his overall academic profile remained uneven. By mid-2010, the intensity of the observations decreased as Ethan's performance began to stabilize. While he continued to perform above grade level in mathematics, the gap between his abilities and those of his peers gradually narrowed as the curriculum advanced. Researchers noted that his early advantage did not develop into a sustained, prodigious trajectory. No clear explanation was identified for the sudden onset of his abilities or their partial decline over time. His case was ultimately categorized as an instance of unexplained advanced cognitive emergence, with documentation indicating that further study would be required to determine whether similar patterns could be identified in other subjects. The final report concluded without a definitive cause, noting that Ethan's performance did not align with existing models of learning, memory acquisition, or developmental progression. His records remained part of a limited archive of atypical cognitive cases, referenced occasionally in discussions of early intellectual anomalies, but without a clear framework to explain how a child with no prior exposure could demonstrate complex skills that appeared to emerge without instruction. The man with unusual resistance to cold. In January 2014, emergency responders in northern Minnesota documented an incident that would later be reviewed by multiple medical institutions without reaching a clear explanation. The subject was identified as Thomas Keller, a 52-year-old mechanic from Duluth, who was found walking along a rural highway during a severe winter storm, with temperatures recorded at negative 18 degrees Fahrenheit. According to the official report filed by St. Louis County deputies, Keller was wearing only a thin flannel shirt, jeans, and standard work boots, with no gloves, hat, or thermal protection. A passing driver contacted authorities after observing him walking steadily against strong winds and reduced visibility. When deputies arrived, they noted that Keller appeared calm, responsive, and fully oriented. He did not display the confusion, slurred speech, or impaired coordination typically associated with advanced hypothermia. He was transported to Essentia Health St. Mary's Medical Center for evaluation. Upon arrival, medical staff conducted a full assessment, including core body temperature measurement, cardiovascular monitoring, and blood analysis. According to hospital records, Keller's core temperature was measured at 98.4 degrees Fahrenheit, within normal range. His heart rate and blood pressure were stable, and there were no signs of frostbite or tissue damage despite prolonged exposure. Physicians noted mild redness on exposed skin, but no evidence of freezing injury. Keller reported that he had been walking for approximately 2 hours after his truck became immobilized due to ice on the road. He stated that he did not feel cold in the usual sense, describing the temperature as noticeable but not uncomfortable. He denied alcohol consumption, drug use, or any prior medical condition that might affect thermoregulation. Toxicology screening confirmed the absence of substances that could alter perception or physiological response. Due to the unusual nature of the case, Keller agreed to participate in further evaluation under controlled conditions. In February 2014, he was referred to the Mayo Clinic for a series of tests focused on thermoregulation and metabolic response. During these sessions, Keller was placed in a climate-controlled chamber where temperatures were gradually reduced to levels comparable to those recorded during the initial incident. Throughout the exposure, his core temperature remained stable, fluctuating minimally within normal limits. Surface temperature readings showed expected decreases, but not to the extent typically associated with cold stress. Notably, his shivering response was significantly reduced or absent, even after extended exposure. Metabolic testing revealed a slight increase in baseline energy expenditure during cold exposure, but not at a level sufficient to explain the maintenance of core temperature without shivering. Brown adipose tissue activity, which is known to contribute to heat production in cold environments, was measured using imaging techniques. Results indicated some activation, but again, not at levels considered exceptional or outside normal human variation. Neurological evaluation showed no abnormalities in the hypothalamus, the region of the brain responsible for regulating body temperature. Psychological assessments did not indicate altered perception of temperature or pain. Keller's responses during interviews remained consistent. He acknowledged that others around him reacted strongly to cold conditions that he found manageable, but he did not describe his experience as unusual until the incident brought it to attention. In March 2014, a follow-up test was conducted involving prolonged exposure to sub-freezing conditions over a 6-hour period. Keller remained seated and inactive for most of the session, a scenario designed to eliminate heat generation through movement. Despite this, his core temperature remained within normal limits, and he did not exhibit signs of hypothermia. Medical staff noted that while his skin temperature decreased, the gradient between surface and core remained stable, suggesting an efficient mechanism for heat retention or redistribution. Researchers considered several possible explanations, including genetic variation, long-term environmental adaptation, and atypical metabolic regulation. Genetic screening was performed to identify markers associated with cold tolerance, including those observed in populations living in extreme climates. The results did not reveal any known mutations or adaptations that could account for his condition. Keller had lived in Minnesota for most of his life, but his exposure history was not significantly different from others in the region. No prior incidents of unusual cold resistance had been documented in his medical records. As the case progressed, comparisons were made to known physiological responses observed in cold-adapted individuals, such as certain Arctic populations or individuals trained in extreme endurance conditions. However, Keller did not fit these profiles. He had no history of specialized training, and his physical condition, while generally healthy, did not suggest elite adaptation. By mid-2015, the investigation had reached a point where no further testing was planned. Keller's case was documented in internal reports and later referenced in a limited number of academic discussions on human thermoregulation. The final assessment concluded that while his ability to maintain normal body temperature under extreme cold conditions was clearly demonstrated, the underlying mechanism remained unidentified. No diagnosis was assigned, and no treatment or intervention was deemed necessary. Keller returned to his regular life, continuing his work without reported complications. His case remained classified as an unexplained physiological anomaly, with notes indicating that current scientific models did not fully account for the observed responses. Despite controlled testing, repeated measurements, and cross-disciplinary analysis, the question of how his body maintained thermal stability in conditions that typically lead to rapid heat loss was left unresolved. The woman who experienced time perception distortion. In April 2012, a case documented by neurologists at Massachusetts General Hospital began to raise questions about the reliability of human time perception under normal conditions. The subject, identified in medical records as Dr. Emily Carter, was a 41-year-old clinical psychologist based in Boston who reported a persistent and measurable distortion in how she experienced the passage of time. According to her initial statement, the condition began abruptly in late 2011, following what she described as a minor viral illness that did not require hospitalization. Within days of recovering, she noticed that routine activities appeared to unfold at an altered pace. Conversations seemed slightly accelerated, movements appeared subtly compressed, and external events felt as though they were occurring faster than her own internal sense of time. Carter did not describe confusion or disorientation. She remained fully aware of her surroundings and capable of functioning in her professional role, but she reported a consistent mismatch between perceived duration and actual elapsed time. In her own written account submitted to physicians, she stated that a minute feels closer to 40 seconds, and that this discrepancy remained stable across different environments and activities. Initial neurological evaluations found no evidence of stroke, seizure activity, or structural abnormalities. MRI scans and EEG monitoring returned results within normal limits. Despite this, Carter's reports remained consistent, and her ability to estimate time intervals was formally tested under controlled conditions. During these sessions, she was asked to estimate the duration of fixed intervals ranging from 30 seconds to 5 minutes without access to clocks or external cues. Across multiple trials, her estimates were consistently shorter than the actual elapsed time, often by a margin of 20 to 30%. Researchers noted that her internal clock appeared to run faster than standard temporal processing. In May 2012, a more controlled experimental setup was introduced. Carter was placed in a quiet, isolated environment with no visual or auditory time references. She was instructed to press a button when she believed exactly 1 minute had passed. Over a series of 50 trials, her average response time was approximately 43 seconds. The deviation remained consistent, with minimal variation between trials. For comparison, control subjects tested under identical conditions showed a much wider range of estimates, but centered around the actual duration. Carter's results suggested a stable and repeatable shift in time perception rather than random error. Further testing examined whether her condition affected cognitive processing speed or reaction time. Standard assessments showed no significant difference from baseline measurements. She did not respond faster to stimuli, nor did she demonstrate accelerated thinking or decision-making. The distortion appeared limited specifically to her subjective sense of elapsed time. Researchers also explored whether emotional state or stress levels influenced the phenomenon. Psychological evaluations indicated stable mood, with no signs of anxiety disorders, dissociation, or depersonalization. Carter herself noted that the distortion persisted regardless of context, including during periods of rest, work, or sleep deprivation. In one documented observation, she was asked to listen to a recorded audio segment lasting exactly 2 minutes. After the playback ended, she reported that it felt noticeably shorter, estimating its duration at just over 1.5 minutes. This pattern repeated across different types of stimuli, including visual sequences and physical tasks. In June 2012, functional MRI scans were conducted while Carter performed time estimation tasks. The imaging revealed subtle variations in activity within the basal ganglia and cerebellum, regions associated with timing and coordination. However, these variations fell within a range that could not be definitively classified as abnormal. There was no clear disruption in neural pathways and no identifiable lesion or dysfunction that could account for the consistent temporal shift. As part of the investigation, researchers reviewed her medical history for any factors that might influence time perception, including medication use, head trauma, or exposure to neuroactive substances. No relevant factors were identified. Blood tests and metabolic panels were unremarkable. Sleep studies showed normal patterns, with no evidence of disorders that could affect cognitive processing. By late 2012, Carter had adapted her daily routines to compensate for the discrepancy. She relied heavily on external timekeeping devices and reported difficulty trusting her internal sense of duration. In professional settings, she used timers to manage sessions and tasks, noting that without them, she would consistently underestimate the passage of time. Colleagues reported no observable difference in her behavior, and her professional performance remained intact. Despite this, she described a persistent sense of detachment from temporal flow, stating that events felt slightly compressed, as if the external world was operating on a different pace. In follow-up evaluations conducted in 2013 and 2014, the condition remained unchanged. Repeated testing confirmed the same degree of temporal distortion, with no progression or improvement. Researchers considered several possible explanations, including subtle disruptions in internal pacemaker mechanisms or neurotransmitter regulation, but no hypothesis could be confirmed through available data. The case was eventually documented in a specialized journal focusing on cognitive neuroscience, where it was presented as an instance of isolated time perception distortion without accompanying neurological deficit. No treatment was proposed and no intervention proved effective in altering her perception. Carter continued to report the same experience years after the initial onset, with no identified cause and no resolution. Her case remained part of a small group of documented anomalies in human temporal processing, referenced in ongoing research but without a clear framework to explain why her perception of time remained consistently out of sync with measurable reality. Thank you for watching until the end, where the edges of certainty fade and what remains are fragments of truth, suspended in silence, waiting beyond memory and time for something that may never fully come into view.